to give us a very professional session. And this time, the last session is very cool because we will talk about some new feature in C# 12, 11, and 10. I will invite Philip to come to stage. Philip, hi.
Hey, how are
Hi.
you all doing?
Yeah. Good morning or good evening or good afternoon.
Good morning. It's pretty
Oh
early
yeah,
here.
it's very early to you. Yeah. Uh, let let me to change the presentation and let you to join and enter your session. Oh, thank you. It's
Hi, everyone. I'm very happy to be back at dotnet Conf. It's been a while. I'm very excited to be here talking about what's new in C#, and we're going to catch up with what's changed over the past couple of versions. There's a lot going on in the language, both, as you've seen probably already, there's some really interesting improvements in C# 12, but we shouldn't forget about the important language features that were added in 9, 10, 11, and even before that. Over the years, C# has had quite a lot of changes to it in terms of things that change how we architecturally look at our applications. Things like async await, generics, pattern matching, nullable reference types. All of these drastically change how we look at building our applications. Now, I think it's quite interesting how the language keeps evolving, but for someone that's been around for a long time, it can be a little bit tricky to keep track of all the changes. So we're going to step back a little bit and look at some of the changes that have been introduced in earlier versions of C#, because they are important to know exactly how to use in your applications. We're going to start off just looking at what was added in C# 9. And I guess one of the major features added to C# 9 was record types. This is a reference type, so it generates some code behind the scenes. The compiler is simply looking at the stuff that you add in your application or the code that you write, and it translates that into code that may have been available in older versions of C# as well, be that the compatible IL with older C# versions too. Some of these features that we're going to look at might depend on changes in the runtime as well, but I'll highlight that as we find those out. We also got a few other things like init-only setters, and records and init-only setters are both something that will help us avoid nulls. Potentially, we're going to be able to get rid of all the null reference exceptions, but we'll get to that as well sooner or later. Now, we also got the top-level statements. If you've ever built a minimal API, you've been seeing the top-level statements. This was added in C# 9 and was really one of the fundamental pieces to be able to more easily get into C#. There's also pattern matching enhancements in terms of a lot more patterns added to the language. And then a few more things that we are going to spend some time looking at. Some of these are more for lower level programming or more very specific use cases. I'd like to focus on two things, that being records, the pattern matching enhancements, and also use these in conjunction with the top level statements. So let's start off with pattern matching. This is a concept that's been around for quite a long time, especially if you've worked with other programming languages before, like F#, for example. Pattern matching is a crucial part of those programming languages and is something that's very natural to the developers working in those languages. So it only makes sense that this would eventually make its way into C#. We've always been able to do what I call matching on a type and air quotes attributes. I'm not necessarily referring to an attribute as that thing you put onto a property, class, or a method call, but as an example here, an attribute could be the color of my instance. For example, the fruit has a certain color, and that's the attribute. The type would be, in this case, an apple. We've always been able to match on this. In C# 1 through 6, we could write some code like this here. There's nothing wrong with this. We all do it, and I still maybe write some code like this or maintain code that looks like this. But then if we have to use this as the concrete type inside that if statement, we'd have to cast it and then pass it on to the method that expects it. There's a lot of code going on here that we could maybe get rid of and make this a little bit more pretty. So in C# 7, they introduced a first iteration of pattern matching. That is in a way for us to use it with a switch. The switch statement allows us to take an instance, and then each case could be the type that we are matching on. In this case here, I could say if the case is an apple, I'm going to capture this as the correct type. I can also apply a when expression or a when clause to say that it has to have a certain value, a method call has to return true, or something like that. But I don't have to do any typecasting myself, which is kind of the fundamental piece of pattern matching. It allows me to say that based on this instance, I'm going to do something, and I can use that as a correct type. With C#8, this was improved quite drastically, because I believe that in C#7, no one really used the switch statement to use pattern matching. But what's interesting with C# and I guess .NET as well in general is that as features are added to both the language and the runtime and the core libraries, they keep improving them with each version. And pattern matching is no different. So with C#8, something called a switch expression was introduced. This here is a way for us to construct something similar to the switch statement, but I can say that I want to create a result based on this object. I can now fill this with expressions. All these expressions can then use patterns. And this is where C#9 comes into the picture, because with C#9, we got quite a lot of patterns added to the language. And they keep adding patterns in C#10 and 11 as well. So now let's just highlight some of the patterns before we jump over to Visual Studio and try to implement them and see how they would work. We saw the type pattern. That's the very basic thing to say that if it's this type, and that is also going to validate that it's not null. So if I say, if it's an apple, if it's a string, if it's whatever type you could think of, then it's also going to ensure that it's not null. We have something called a positional pattern, which is used together with the deconstruct method. A property pattern, so I can match on properties. There's a tuple or tuple pattern, but depending on how you'd like to pronounce that feature. A relational pattern. Think about the relational pattern as a way for us to say, based on, for example, a property, the value has to be greater than or less than a certain value. We can then use this in conjunction with the conjunctive and pattern to say that the user's age has to be between 18 and 45, or whatever age range you'd like to define. We can also exclude values by introducing a disjunctive or, very much like we use if and else statements to do and or operators. We also, in C#11, got list patterns, which makes it easier for us to match the content of a list, slice it off, and also use this together with a span. Then we can parenthesize this to make it a little prettier, but I reckon that if you have to rely on the parenthesized pattern, you're probably writing a little bit too much code. We can negate the pattern by using the not pattern, and we can also use all of these different patterns together, and they will then be using what's known as a recursive pattern. Now, how about we actually jump over to Visual Studio and look at two things. I'd like to look at both the record types as well as the pattern matching improvements from C#8 to C#12. So let's jump into Visual Studio. And the first thing I'm going to show you here is the record type that I've created for this sample. This is a very simple type. I've defined that this is a record. It has a primary constructor that defines that this type will take two parameters. It requires the number of attempts and the date that you tested on. So this could be a test at university, or it could be whatever, right? And then I have two subclasses or subrecords that are inheriting from the test result. They could then add their own implementations, or they could, in this case, be simply used to define that you passed or failed. They don't necessarily have to add more fields to them, even if that might have made a little bit of sense. So what's the difference then between using a class and a record? You might know now that a class also supports the concept of a primary constructor. The difference is that with the records, they generate quite a lot of code. So I've got an application here running in the browser called SharpLab. I've constructed a record here to say that I have a record of person. We could have used the same thing with the record being the test result. But what this is doing here when I add record and then the name of the reference type is that it's going to generate quite a lot of code for us. It's going to generate a class that's going to implement the IEquatable. And this will introduce backing fields. It will introduce the publicly exposed properties, which is why we should probably name this properly so that it will generate a nicely looking publicly exposed property. And then what we also get with record types is immutability, which is extremely important when we are working in multi-threaded or asynchronous programming. And then we also get value-based equality, because if we scroll down here, we can see that it overrides the equality operator. And what this will do is that it will ensure that when you compare two instances, it will compare the fields. So if I had two people in this case here, it would compare the names instead of the references. So with that knowledge, we can now assume that we understand a little bit more about records and how they work. And the way they're different from the new primary constructors on classes is that primary constructors on classes don't really generate more than the backing field for whatever thing you want to have in your primary constructor. So this record simply has another additional method just to show you that you can have a method on a record. Now, this is a special method called deconstruct, which we're not really going to look more at here today. Instead, I'm going to head over to my program file here where I'm using this record. I have a method down here at the bottom, which is going to return the base test result, but I'm creating an instance of a failed test. This could be coming from anywhere. So I'm going to get the last test. Think of this as getting the person's last test they did at university. Now, I'm not sure what this is going to return, right? It could be anything. It could be returning something that's a failed pass, or maybe I want to evaluate some of the properties or a range on this particular type. So what I'd like to do is that I'd like to construct a string that determines the outcome of this test. So I could say that the outcome will be based on my result, and I can now introduce a switch expression to say that I'm going to now provide this with patterns to determine what this is. And the first pattern that I'd like to add is to define the default case. We can do this in two different ways. I can use a discard to say that, well, I don't really care about the value. This discard can be used for a lot of different things, but in switch expressions, they're used to define the default. So I could say that, well, I don't know what this is. Because what's interesting with the default or the discard here is that it could match on anything. It could be matching on null. It could be matching on something that we don't have. It has to be of the same base type, but other than that, it can be whatever. Now, I can also use the var pattern, which would let me capture this. If I capture this here, this is going to be a nullable test result, which I can then use inside my pattern here on the right-hand side. I could be passing this into a method, or I could simply be using some property values. What you should know, though, about the var pattern is that it's going to match on null. So you'd have to null check whatever you access on this type, which is why I do prefer using the discard. Now, I'm going to add a couple of more patterns. I could, for instance, say that, well, if this is passed, I'm simply going to write the text passed, and I could also add failed. What's just the same as with switch statements, you have to add the more granular ones at the top. I couldn't add a recursive pattern to say that if it's passed, as well as the number of attempts is less than 10, I couldn't do that here because it's going to tell me that it's going to be unreachable, just like with normal switch statements. So I'd have to move it up a little bit to the top here. And now what I've done is that I've introduced a recursive pattern. I've said that it has to be passed as well as have a property value that is less than 10. I could also use the conjunctive AND pattern, for example, to say that, well, it has to be, it has to be greater than 0 and less than 10. Of course, with the number of attempts, this probably doesn't make a lot of sense, but you can use this quite nicely. Now, what's interesting with the pattern matching is that I don't have to match on the particular type. I could, because this would now let me capture this as the actual outcome, the result. If I write the result here, this is going to be an instance of the passed test. I can now use this again inside my expression, or at the right-hand side of the expression. And then I want to show you one more thing here, is that if I remove the pass or the type pattern, this is still going to work, because this part here is going to be the property pattern together with the relational pattern and the conjunctive AND pattern. So what does this thing do? It will do two things. It will make sure that it's an instance of an object before it tries to access this property. And a way to show you how this is also improved with C#10 is that I can now, this here is a nice way of saying that this has to be an instance. I could then say that I want to look at the test date, which is a date time or datetime offset. If this would be another reference type that could be nullable, then accessing, for example, let's say year, the year property, the year has to be more than 2000. In C#10, they improve this so that this accessing or this accessor will also ensure that this instance is not null, which is tremendously useful because you don't have to do null checking all over the place. So you can use the patterns in quite a lot of different ways. You don't have to use them together with the switch expression. You can, in fact, use them with an if or else if as well. So where this would make sense is that I could say, well, if the result is an instance, maybe don't do null checking like this because it's not as readable. We could say that not null, and this is where you'd use the negated not pattern. We could also say that it has to be null by inverting that it has to be an instance. Again, if you write patterns that don't make any sense, our code is going to get a little bit ugly. So we should probably try and avoid that and make sure that we express ourselves in ways that would make a lot of sense to whoever's using our application. So patterns are extremely useful together with both records and classes. They provide a way for us to define portions of code or express ourselves that surely enough we were able to do before, but now it translates more into business lingo, I would say. So another example of using pattern matching, I'm going to head over to another example here from C#11, where I'm using a list pattern. This here has a payload. I have a byte array that simply represents some payload of data. It could be a string or whatever. Now what I'd like to do is that I'm going to introduce a list pattern. I can say that if my payload is exactly matching this list pattern, which means that the first element has to contain this value, and I don't care about the rest of it. This here is the same as using the spread operator or the range syntax. It's simply a way to define that I don't care about the rest of the elements. What's interesting as well is that I could say that I'm going to capture this as the payload, and I could then access this exact byte array that I'm matching on, because this here could be coming from a method call. Now, this avoids having me to store this in a local variable first before using it. I can also use a slice pattern with this list pattern to say that if we look at this next portion, I can say that if the payload is exactly 0x1, and I don't care about the second element being 0xf1 in this case here, I'm going to capture the rest of this array as a little slice of byte array. So this is cool because now I'm going to get a new byte array with these two values. If we were using spans instead, there wouldn't be any additional allocations, which is also tremendously useful. Finally, with the patterns, there's the span pattern. In this case here, I have a read-only span of a char, which simply set to my name, and I can use the span pattern to say, well, if the content is exactly my name, it's going to ensure that this is matched properly, which makes it easier to work with some types of data. So again, patterns and pattern matching is really useful, and it's something that you should probably be adding to your applications. If you use the tooling in Visual Studio or Writer or ReSharper or whatever, or VS Code for that matter, it's going to tell you when you can refactor your code into using patterns instead. And in a lot of cases, it makes the code a little bit more readable. So with that being said, let's look at C#10 and see what's been added to this version as well. The records were improved a little bit more by also allowing them to be used on structs. Now, a big difference between record classes, which is actually what we were looking at in C#9, is that with record structs, they're not immutable by default. You'd have to define that they read only in order to make the struct immutable, which is fine if you know that little gotcha. They did some improvements to the language in general. They introduced global using directives, file scope namespace declarations, and this is, again, improving the way that we can work with minimal APIs or that style of applications. So even if they introduced the first iteration of top-level statements in C#9, they gradually improve this in each version of C# to make it more intuitive to work with top-level statements or applications like it. They introduced the extended property pattern that I just showed you, so you don't have to manually perform a null check on that property. They did some improvements to lambda expressions, and that's not what I wanted to do. For some reason, my clicker went rogue, so let's do this. They also introduced constant interpolated strings, or allowed you to do const and interpolated strings, and some more minor improvements as well. In terms of the inferred delegate types, or the improvements to using delegates, in C# 9, you had to explicitly define which type of delegate which type of delegate type your lambda was producing. In this case here in C# 9, I have to say that this is a func of string of int, but why couldn't the compiler figure this out for me? And in fact, that is exactly what it could do. In C# 9, you were required to explicitly define this, but with C# 10, it's going to figure this out for you. It's kind of a small adjustment or improvement with the compiler, but as you'll see with many of the features in C# in general, is that they let you write less code and be as powerful and as expressive as you were before. So I think this is a nice addition to the language as well. Now, again, to talk a little bit more about the minimal APIs, one of the things they had to add was attributes in lambdas, because everything in a minimal API is basically relying on the attributes. And what's interesting with this is that if you were to write older style applications like ASP.NET Core MVC or ASP.NET Core even older, or ASP.NET, then you know that you want to apply attributes on your inputs to your actions. And you weren't able to do before, but now in C# 10, we can append the attributes on the lambdas. And this particular attribute will simply tell ASP.NET Core that it's going to grab the value from one of the headers, if that's available. Now, before we jump back into Visual Studio, I'd like to also just highlight some of the things in C# 11. I showed you the list pattern, slice pattern, and span pattern already, but again, they improved the pattern matching with C# 11. I'm not surprised they didn't add more patterns in C# 12, because there's still a lot to get adjusted to as a developer of C# and .NET. So maybe in C# 13, we're going to see one or more patterns added to it. I'd love to know if there's one that you find missing in the language. They also added name of parameters. They're caching delegates for static method groups, which is a performance improvement. I know that there's been a huge focus on performance during .NET Conf, and one of the reasons this is possible is because of work like this. The compiler tries to make really smart decisions, while the core libraries are also improved together with the runtime. So they all play a very important role in making everything more performant. We also got something called a required property. The required properties are also something that you will use together with the nullable reference types. And I'm going to talk more about this in just a moment. We got a thing called raw string literals, static members and interfaces, UTF-8 string literals, and generic math support, generic attributes. And then what's interesting with C# 11 is that this is the first version of C# where they actually withdraw one of the language features before it was released due to some community feedback. And I think that this highlights the importance of contributing on GitHub, being a part of the discussions around how you'd use this in your products, how this would affect your applications, and if it makes sense or not. Now, for parameter null checking, for a lot of developers, this was really great, and for the other half didn't like it at all. So it was kind of a divider, and therefore didn't make it into the final cut. Now, there's one big problem that I'd like to talk about, and that's nullable reference types, or null reference exceptions. Now, I'd ask for a raise of hands how many of you have seen this, and I do hope that some of you might not have seen this yet. And with newer versions, as of .NET 6 and C# 8, this is hopefully no longer going to be as common as it was before. There's a big problem, though, with nullable reference types, or reference types in general, that allow you to be null, and that's that we can get exceptions like this here. I'm going to jump over to Visual Studio, and we're going to spend some time just looking at how we can handle nulls in C#. With C# or .NET 6, as I mentioned, they've added this thing called the Nullable Context. So by default, your applications or your C# application will now look at all reference types a little bit differently than it did before. With this enabled, what it will do is that every reference type is going to be assumed to be set to an instance. That means that if I go into my program, it's going to give me a couple of warnings because the compiler can't figure out if I've set this string to an instance or not. And surely enough, what I can do now, since the string here is now supposed to be set to an instance, if I want to make it optional, I can use the question mark, just like you did with nullable value types in older versions of C#. Same applies in C#, in C# 8 and onwards. But the problem here is that I don't really want my first name to be optional. And one of the things people tend to do then is that, well, I want to get rid of the warning, so I have a couple of different options. I could introduce a constructor, but the problem with introducing a constructor is that I now have to change the contract. That's not the type I want, first name. And it's still going to tell me that, well, you should probably set first name to a value. The compiler deems that the constructor should be in charge of setting this to an instance. I don't want that because it changes the contract. Everyone that's using my constructor will have to then pass that value. Instead, what I saw a lot of people do is to say, well, I don't care about this being null at the first because I'm going to set this to a value. And if I set it to null, I want to get a warning. So the warning disappeared, but I'm still going to have a problem because this is clearly going to be null. The default value of string is null, and this dammit operator, more probably better word for it, is the null forgiving operator. I don't like to do this. So instead, we're going to use a feature from C# 11, which is the required keyword. So now, whenever I create an instance of my details class, I'm going to require this to be set. I'm going to require the details on the person to be set as well. They're all init-only properties, which is a new feature from C# 9 that allows you to set it once, and then after it's immutable, just like your records. Now, there's a method up here where I'm going to get a little bit of a warning telling me that you should probably null check the last name because I can't promise that this is not null. I can use the null conditional operator before accessing that property, or the compiler is super smart. I could say, well, if person.details.last name is null, we are going to return or continue or whatever. And by using something known as null state static analysis, it's going to figure out exactly what's happening here. So I fixed the potential problem here, and the compiler is helping me figuring out where this could be a potential problem, which is really the benefit of using the nullable reference types. There's another problem in my application here, and before I actually go down to that, I also want to show you that it's smart enough to know that if I use the argument null exception, let's do person.details.last name. Again, it's using null state static analysis because this method is decorated with an attribute to say that if the first argument is null, it's going to throw an exception, and therefore the next line won't execute. So there's another problem here. I'm returning null, and I could say, well, again, use the dammit operator to say that I forgive this to be null, or I could also say that I allow this to return null, and maybe the list can contain null values as well. We don't want our code to contain question marks or exclamation marks all over the place. So instead, it would be better to return a new instance. And this here is the target type new expression, which required a runtime change when this was added. It's going to tell me that, well, actually I have to use yield return here because it's an IEnumerable. And it's going to complain again because I have to set details to an instance. I have to set details to a new thing as well. It can figure out what I want to set. And we can see here that first name is, in fact, required. If I remove this again, it's going to tell me that you're required to set first name. So extremely useful and something that's tremendously important to the language. This is the default since .NET 6, and I do encourage everyone to enable this. Together with treat warnings as errors, this is a very funny thing to add to your applications. It's going to make a lot of coworkers a bit angry. Now, finally, there's one more thing I'd like to show you, and that's the UTF-8 string literals. Everything in C# is traditionally UTF-16. And having to convert it back to UTF-8 would take a little bit of time. So this code is pretty much allocation-free to allow me to slice my name into first name and last name. And finally, this is a raw string literal that is really useful as well. So I can use JSON, and I get syntax highlighting and so forth. Now, we've got a couple of minutes left here, or 1.5 minutes. So I'm simply going to tell you that in C# 12, you probably saw the primary constructors, the collection expressions. Inline arrays is new as well. Optional parameters and lambdas, ref read-only parameters. Alias anytime. any type, and the experimental attributes, as well as interceptors. For me, the probably most important one is the collection expressions. This is a new way of producing a collection, and I can also use this together with a spread operator. And then also getting the primary constructors added to the language, just as we've saw with the record types. This is really useful and a good feature to C# 12. Now, with that being said, you should download .NET 8. And my name is Philip Ekberg. Thank you so much for tuning in. I hope you enjoyed the rest of the conference. Thank you so much for this. And I'll take any questions on Twitter, and I'll stick around for the rest of the day.
Thanks, Phil. I think I found some question in the comment. I saw this question. Do you know this? Can you see here?
Yeah, I feel like null is an anti-pattern, or null exclamation mark is an anti-pattern. Yeah, you should probably not use the dammit operator at all. To be honest, you should try to adhere to the other principles and make sure that you return an instance. Only use the null forgiving operator in the very last resort.
Okay. Another question is, so here.
What if JSON or XML deserialization produces null value to field that is not null field? So that depends on this deserializer. You can probably set it to throw an exception, but in most cases, it could still yield a null result. So you can still set it to null. There's no guarantee that you don't do it, because you can do equal to null exclamation mark, like we saw in the other question as well. So when you're doing deserialization, just ensure that you do some checking as well afterwards.
Okay. The last question is here.
How do you do null reference checks in primary constructors? Well, you simply say that they're not null, and the idea is that you don't have to. So when you pass an instance into that class, the idea is that if the compiler can figure out that you're passing null, you'll get the warning somewhere else. Okay. So you don't do the actual null check in the primary constructor.
Okay, thank you, Phil. Very good session, very good topic, and very good content. I learned more about this. See you next time. Bye-bye.
See you. Thank you. Bye-bye.